Industrial facilities are usually shut down after something fails. Machinery breaks down, supply chains collapse, demand disappears, or external pressures make continued operation impossible. In most cases, production slows before it stops, and closure follows visible decline. What makes this facility different is that none of those conditions applied. At the time it was shut down, the plant was operating within its designed parameters. Equipment was functional, output targets were being met, and the workforce was in place. Production had not collapsed, and the facility was not obsolete. It was still producing when operations were halted, making its closure a matter of decision rather than necessity. During the 20th century, large industrial facilities became central to national economies and military planning. Factories producing steel, fuel, chemicals, and components were often treated as strategic assets. Their output supported not only civilian markets, but also defense readiness and long-term infrastructure development. Once built, these facilities were expected to operate for decades, with incremental upgrades rather than wholesale replacement. Shutting one down carried economic, logistical, and political consequences that extended far beyond the plant itself. The facility at the center of this case was constructed to support continuous, high-volume production. Its layout reflected efficiency rather than experimentation. Raw materials entered at one end, finished output exited at the other, and internal processes were optimized for scale. Power systems were designed for constant load. Maintenance schedules were established to prevent unplanned downtime. From an engineering perspective, the plant was stable, predictable, and reliable. Operational records from the period show that the facility met performance expectations. Output remained consistent, quality standards were maintained, and downtime was within acceptable limits. Staffing levels supported round-the-clock operation, and supply inputs were sufficient to sustain production. There were no reports of systemic mechanical failure or resource shortage. Unlike facilities shut down due to disaster or economic collapse, this plant was not failing in its primary function. The decision to shut down the facility emerged from broader reassessment rather than immediate pressure. Over time, planners began to reconsider how the plant fit into evolving industrial and strategic frameworks. Changes in technology altered production requirements. New methods reduced the need for centralized, high-volume facilities. While the plant remained capable, its role within the larger system began to shift. Cost analysis played a significant role in this reassessment. Operating a large industrial facility involves ongoing expenses that extend beyond production itself. Energy consumption, workforce support, regulatory compliance, and long-term maintenance all contribute to operational cost. Although these expenses were being met, alternatives emerged that offered similar output with lower long-term commitments. The facility was not inefficient, but efficiency alone was no longer the sole metric guiding decision-making. Infrastructure age also influenced planning. While the plant remained operational, many of its systems reflected design standards from an earlier period. Control mechanisms, monitoring equipment, and production layouts were reliable, but inflexible. Modernization was technically feasible, but it would require significant reinvestment and disruption. Continuing operations without upgrades preserved stability, but it also limited adaptability to future requirements. Geographic considerations further affected the plant's long-term outlook. The facility's location had once offered logistical advantages, including proximity to raw materials and transportation networks. Over time, changes in distribution models and supply routes reduced those advantages. Competing sites closer to end users or energy sources offered greater efficiency. The fixed position of the plant constrained its ability to adapt to these shifts. Environmental and regulatory factors added another layer to long-term assessment. Standards governing emissions, waste handling, and energy use evolved over time, affecting older facilities more heavily than newer designs. Compliance remained achievable, but it increased operational burden and administrative oversight. Maintaining compliance did not threaten immediate operation, but it contributed to cumulative cost and complexity. As these considerations accumulated, planners evaluated alternative approaches to meeting production needs. Smaller, distributed facilities offered flexibility in scaling output. Outsourcing and international partnerships reduced reliance on domestic, centralized plants. Advances in automation and logistics allowed production capacity to be reconfigured with less dependence on single sites. These alternatives reduced vulnerability and improved responsiveness to changing demand. If you find this kind of long-form analysis useful, subscribing helps the channel continue producing videos like this. Importantly, this reassessment did not reflect dissatisfaction with the facility's performance. The plant continued to operate effectively and meet production goals. Its shutdown was not a response to breakdown or inefficiency. Instead, it reflected a shift in priorities, where maintaining existing capacity became less important than reallocating resources toward more adaptable systems. The shutdown process reflected this perspective. Operations were wound down methodically rather than abruptly. Production schedules were adjusted, inventory was accounted for, and equipment was secured. Workforce transitions were managed through reassignment or phased reduction. There was no emergency closure, no immediate threat, and no need for rapid denial or dismantling. Once operations ceased, the facility remained largely intact. Machinery was left in place, utilities were disconnected in an orderly manner, and buildings were preserved. The site did not display the damage or neglect associated with sudden abandonment. Instead, it entered a period of dormancy, reflecting a pause rather than a collapse. Over time, the facility became a reference point in discussions about industrial transition and long-term planning. Analysts used it as an example of how production capacity can become misaligned with strategic direction, even when technical capability remains intact. The plant's closure illustrated that operational success does not guarantee permanence. This case highlights an important distinction between performance and relevance. A facility can fulfill its function effectively while no longer fitting within evolving economic or strategic frameworks. Industrial systems change, and assets built for one era may lose alignment as conditions evolve. In such cases, shutdown represents adaptation rather than failure. The industrial facility that was shut down while still producing challenges common assumptions about abandonment. It shows that closure does not always follow breakdown or decline. Decisions about production are shaped by broader considerations, including cost structure, flexibility, and long-term alignment. The plant was not overwhelmed by circumstances. It was set aside because its role had changed. For planners and historians, this example underscores the importance of evaluating systems within their wider context. Production output must be weighed alongside adaptability, sustainability, and strategic fit. When those factors shift, even successful operations may be retired in favor of alternatives better suited to future conditions. If you want more analyses of military and industrial systems that were abandoned on purpose, subscribe to Echoes of War. This channel examines why structures, machines, and facilities are left behind, not through spectacle, but through explanation. In the next episode, we'll look at a transport aircraft program that met its technical goals, but was quietly withdrawn from service.